A group of grade 10 students were on an educational tour with their math teacher. As they passed a school building with a flagpole on top, the teacher asked, "Look at the flagpole above the school building. Can you measure its height from the ground without actually measuring it?" "Yes, using a clinometer," Rakesh quickly responded. He had heard about it from his elder brother, who is now in grade 12. The rest of the students were curious, so the teacher said, "You will learn about this when we study heights and distances in trigonometry. But before that, you can build one at home as a fun vacation activity." "What is trigonometry?" Rima wanted to know. The teacher said, "It's the study of relationship between the sides and angles of a triangle." Hello everyone, welcome back. Today I am going to show you how to make a simple clinometer, a tool used to measure angles. It's a fun and easy project, perfect for math and science experiments or outdoor activities. So without any further delay, let's get started. You have two good options. I shall teach you both the types. To make a classroom protractor clinometer using small protractor from an instrument box. Materials needed: a protractor, a straw, a piece of string, a small weight like metal washer or metal nut, tape if required, a pointed object for making a hole. Now how to make it? Tape the straw along the straight edge of the protractor. Use sharp object to create a precise hole. Tie one end of the string to the center hole of the protractor with the weight attached to the free end of the string. That's all. Your clinometer is ready to use. This is precise, easy to use and already marked with angles, making it ideal for quick classroom experiments. Next is the DIY protractor from cardboard. Materials needed: poster board or cardboard. To bag the printout of the paper protractor and a pencil for drawing outline. Printout of the paper protractor, or you can draw angles manually or print a protractor template to attach to the cardboard. A straw, a piece of string about 10 to 12 inches, a small weight like a metal washer, clear tape if required, glue and scissors. Now you can follow the steps given to make a cardboard protractor. Here are the steps to make a cardboard protractor. Cut out the protractor shape on a cardboard. Use thick paper board, sharp scissors to ensure clean edges. Print the protractor template. Choose a high quality stiff paper for better precision. Glue or tape the printed protractor on the cardboard cutout. Carefully cut the cardboard to match the shape of the printed protractor. If your clinometer design needs a center hole for the string and weight, use a sharp object to create a precise hole. Verify the accuracy by using a real protractor or digital tool to ensure they align correctly. Now that your clinometer is ready, how to use the clinometer? Hold the clinometer up to your eye and look through the straw towards the top of an object. You can choose a tree or building, lamp post, flagpole on the top of a school building. The string will hang freely and align with an angle on the protractor. That is the angle of elevation. You will need two people, one to look through the straw and sight the top of an object, and one to read the degrees that the string makes with the protractor. The next step is very important. Find a tall tree or building in the place where there is plenty of space to move away from the object that you are measuring. Measure the distance from where you are standing to the object. Now let us discuss the different methods how to measure the distance from where you are standing to the building. Using measuring tape, counting steps, students can measure their own step length first to be more accurate. If you have 1 meter stick or ruler, measure 1 meter at a time until you reach the spot. For quick estimation outdoors, students can practice stepping 1 meter per step. Pedometer, the instrument that counts steps, is called pedometer. It tracks the number of steps you take, usually using a small motion sensor. Modern versions are built into smartphones, smartwatches, and fitness trackers. Let us apply what we have learned using a clinometer. If you measure a 45-degree angle to the top of a tree and you are standing 10 meters away, what is the height of the tree? Apply tan theta is equal to opposite side by adjacent side. You will be learning trigonometric ratios later. Look through the straw of your clinometer and spot the top of the tree. You move forward and backward until the clinometer shows exactly 45 degrees. Ask a friend to read the angle where the string touches the protractor. Confirm it's 45 degrees. Measure the horizontal distance from where you are standing to the base of the tree. Now let us say it's 10 meters. Measure your eye level height from the ground. Let us suppose it's 1.4 meters. What is the height of the tree? Since tan 45 is equal to 1, opposite side is equal to adjacent side, that's equal to 10 meters. You can see the picture here. It clearly gives you the answer. Total height of the tree is equal to 10 meters plus 1.4 meters, which is equal to 11.4 meters. Now why does this work? Because triangle ABC is an isosceles right-angled triangle. This clinometer is a simple but powerful tool for measuring angles in the real world. Give it a try and let me know what you think in the comments. If you enjoyed this tutorial, don't forget to like, share and subscribe for more DIY projects.